Hi, welcome back to the Statistic Lecturing Series. We are still in the unit Expected Value, and we talk about the moments. And this is our third video. And for the first two videos, we covered different type of the moments about the origins, moment about the mean, and we'll also talk about the Chebyshev's theory. So basically, Chebyshev's theory is try to put together the first moment and the second moment, the mean and the variances together, and see how that play a role in the probability distributions, right? Now, the third video is very, very important topic also, is what we call is the moment generating function, MGF, okay? And so before we look at what is our definition, so let's take a look at what is the moment generating functions here. Okay, so we talk about the MGFs, right? So this is, we call this the moment generating functions. Yeah. Okay, so what is this? All right, it is a function. And what is this function for? Generating function. So that means this is the function can help us to generate moments, right? So we talk about first moment, second moment, so we did that. And so each time, like when we talk about the first moment, we take the integrations for the summation, like the first moment, like EX, so we say, okay, you do like this, right? The f of x dx, then like if you have an EX square, and then you do like this, right? F of x dx, and then find out whatever is here. So the moment generating function is a function itself. And then they have a general form. By using this function, I can generate any type of the moments I want. I can generate a third moment, a fourth moment, a fifth moment. Okay, so like in this video, I'm going to focus on two things. First thing, all right, so what do you tell me? This is a function. So what is the moment generating function looks like? Then the second thing I'm going to show you is, all right, you tell me they can help me generate the moments. Now how I'm going to use this function to generate the moments here, okay? And it's really very neat. Okay, so the first things here, let's take a look at the moment generating functions. The definitions here. So the way we use here, this is MXP. That's the notation we use. And what is X? X is your random variable. So the moment generating function, the definition is pretty easy. Let's say, hey, this is just you try to find the expected value of this function. What the function? Exponential function. So it's e to the tx. All right. So that's what we said. This is a moment generating function. So based on the x is discrete or continuous, you have a two-way. If it's discrete, you just do like whatever we did here. You said this is e to the tx, then the f of x. You add all the values, right? Now, if this is continuous, then you just integrate, then the e to the tx, f of x. Correct? So, from the definition, all right, so this is very easy definitions here. Okay, so that you just try to find the expected value of the ETX, and then you use your calculus skill to get it. Okay, so now let's take a look. How am I going to use this function, whatever they come out? How I'm going to use it to generate the moment. All right. Okay, so the first thing here, for this function, e to the tx here. All right. So if you don't remember, you need to go to review and in the calculus 2. So you need to calculus 2, you need to go to review what is the Maclaurin series here, all right? So it's kind of like the Taylor series with a special, like the center is 0, right? So the e to the 2 xt. So in here, I'm not teaching the calculus. So I'm going to assume you're going to go home to review. So you know how to find the Maclaurin series of the e to the tx. And now I'm just going to write it. So the e to the tx is just 1 plus tx plus, okay, 2 factorial t squared x squared plus 3 factorial t cubed x cubed. Oh, it's cube. Why write x fourth? Ah, okay, so x cubed, then plus 4 factorial t fourth x fourth, then da 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 da. Okay, so the da 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 is here, right? And now by the definitions here, so I know the e to the tx is my moment generating functions, right? Okay, so now that means I'm integrating from the infinity to negative infinity to infinity. So this is 1 plus tx plus 2 factorial t squared x squared plus 3 factorial t cubed x cubed plus 4 factorial t fourth x fourth da 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 da, and f of x dx is here. So I can break it, correct? Yes, when you integrate, so you can break this is infinity. So this is 1 to the f of x dx, then plus negative infinity. So this is t to the x f of x dx, and then plus negative infinity. Here, this is t squared x squared, and 2 factorial f of x dx, and da 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 da. All right, and now in here, okay, take a look here. So this one's here, if you integrate from the whole range, what is here is 1, right? Because you add all the probabilities 1. And for here, this is t. So t is a constant. You can take to the front, right? So if you take t to the front, then what is this integration? X to the f of x is what? Is the first moment, right? So this will be t times what? Times mu, right? All right, because mu 1 prime, remember we said the mu 1 prime is equal to mu, right? So that's why it's mu. Okay, now if you take a look at this one's here, right? So you have a t squared, you have factorials, right? And then what is inside your integration is x squared f of x, right? Okay, so now the second term you can take it out. So what is here is t squared 2 factorial. And what is this one? X squared f of x. What type of moment is that? That is the second moment about origin or mean. That's the second moment about the origin. So right, so then we have mu 2 prime. So the same way for the cube, right? So the same way I did not write it, but the cube, this is t3, this is 3, then it's x cubed, right? So what do you have here? So you have the, this is t3, 3 factorial, mu 3, so it's the third moment and the central, right? So you just do da 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 here, the r's terms, right? So any r, so it's r's factorial, t to the what? T to the r, then mu to the r's moment primes, right? Da 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 da. Okay, so this is also, we said this is our mxt's here, right? Okay, I'm going to show you how to use this one to get the moment, right? So let me go to the next page. See here, we don't have enough space here. Okay, so I need to rewrite it. So this is just from the previous page. mxt is equal to the 1 plus mu t plus 2 factorial mu 2 prime and what? And the mu 2 prime and okay, so the t squares, right? Then plus t cube 3 factorial mu 3 prime and write one more term, t4 is 4 factorial mu 4 prime and the da here r factorial pr and the mu r prime da. Okay, so now let's take the derivative, right? So I'm going to take the derivative. So I'm going to take the first derivative of mxt. I'm going to take a dt. All right, so I'm going to take the first derivative. Okay, so if you take the first derivative, respect to what? Respect to t's, right? Okay, so now let's take a look. What happened to 1? Cancel. So what happened to here is mu. That's right. T become 1. Then plus, what happened to here? So this will be 2t, 2 factorial, mu 2 prime. Okay, now what happened to here? So this is 3t squared, 3 factorial, mu 3 prime. Right, and then take what is here. This is 4 factorial 4 t3 mu 4 prime and the da plus r t r minus 1 r factorial mu r prime da. Okay, so now if this is my first derivative, right, mxt dt, if I let the t equal to 0, so what do you get here? If t equal to 0, every term with t will become to 0. What do you have? Oh my gosh, I got a u. My gosh, I take a first derivative. I have a first moment. Oh boy, that is very beautiful. Correct? Okay, let's try to do again. Let's say, okay, I'm taking the second derivative. Okay. Okay, so this is dt to the second derivative. So if I'm taking the second derivative, that means I'm taking the derivative of the first derivative, right? So mu become what? 0. Okay, so in here, t, 2t, so t take a derivative become what? It's 1. So 2 over 2 factorial is what? It's 1. So this is mu 2 prime. Okay, so now take a look at this ones here. This one, you take the derivative again. So this is 3 times 2 times t, and this is 3 factorial. And this is what is mu 3 prime. Okay, so take a look at this one. This is 4 times 3 times t to the square, 4 factorial, mu 4 prime. Da here. So this is r minus 1, t to the r minus 2, r factorial. This is mu r prime, Correct? Okay. Now let's set the t equal to 0 for the second derivative. So mxt, right? And then this is dt2. I let the t equal to 0. Okay, so take a look at the t equal to 0. All this one with t. So what is here? Mu 2 prime. Oh my gosh, right? So you find the moment generating function. And then you take the first derivative, set t equal to 0. What did they give you? The first moment. If you set the second derivative, then what do they give you? It's the second moment of the origin. So that's why I can use the moment generating function to get the r's moment. So this is why if I take the derivative r's time, the moment generating function xt the dt r time. So if you continue to take the derivative, right? So what is here? I'm going to get a u r prime. That is, how do I use the moment generating function to generate moment? Okay, so now I'm ready to take a look at our notes here, right? So the notes here will tell you what is moment generating function. It's very easy. It's just the expected value of the ETX. So if it is discrete, you summation. If it is continuous, you integrate. So now this one's here, the theory number 5 is super, super important theory. This is to tell you how do you use the moment generating function to find the moment. Then they say, hey, it's easy. You just take the derivative. If you want to find the second moment, you just take the derivative twice. If you want to find the fourth moment, you just take the derivative 4 times here, right? That is super beautiful, right? So that's how do you use the moment generating function to find the moment here. Okay, so now the next one's here. They'll tell you, say here, they say, okay, so those are, they say, how about if you have linear combinations of your random variables here? Then how do you do it? So this is the one, is probably is easy. And also is like the people, most likely if they want you to prove, it's pretty easy to prove, right? So let's take a look at number 1 here. Let's see how to prove it. If this is the one, they say, hey, this random variable is x plus a. So what is the moment generating function for this random variable? You will say this is e, so it's a t, the x plus a, that's right? So then you use the exponents, you say e, so this is a tx, right, plus ta, correct? And then this will be equal to the e, the tx times e to the ta, right? Because you use exponents, you multiply, you add. And now, hey, these numbers here is a constant, it has nothing to do with what? To do with a. So I can take a look, I can take the ETA out. And then this is the E, the TX. Oh boy, so what happens here? This is my moment generating functions, right? So that's why would be the ETA times MXT. That's how do you get your first ones here. Okay, so now let's take a look at the second ones here. So you have N dxt. So how about if you times the constants, right? So when you times the constants, so you will do the same way. So you say this is the E T dx here. Okay, so that means you integrate E to the bx. So now in here, right? So in here, you can kind of doing like we call this like a kind of, you can treat this is a new t, right? Doesn't matter because that constant. So you can treat this is what? This is kind of like a t star, like a tb's, right? So now basically, then what do you have here? So this one will give you, so it's the random variable x. Then what is your inside here is bt. Or you can say it's t stars, right? So it's t star, but t stars equal to bt. So this one is super easy to prove also. Then the number 3 is here is a combination of the first 2. So if you have a linear combination, it's like x plus a to the b, the t. So you still do the same. So you say this is the expected value t, then this is a, the x plus b, correct? Okay, so now this one's here, you can say this is the E. So you separate the EA, right? Okay, so now this will be E to the E, the T over A, the X, and the times E, T, the B, A. So the same things here, this is all constant, right? So you'll be able to what? You'll be able to move the constants out. So this will be E T times BA. And then this is expected value E T A X. Then like we say, this is, you can treat this is as what? You can treat this is as new T stars, right? So what is the final answers here? So this will be ETB over A. Then this is MX. What is your new T here? T over A is here. Oh, I switched the A and the B in here. All right, but it's fine. I just switched that. So I guess you guys, I did not pay it. So A plus B. Okay, so I switched right in here. Terrible, terrible. Okay, so let's try to, but basically I did not pay attention here. All right, but it's the same things here. So this is A, this is B. So the B has to be on the denominator. And so it's the same things, okay? So here, this is A. All right, so here now, I see here, it's not careful. Now let's make a mistake. So this will be, X over A, X over B here, right? So this is X over B, and the T, this one. Okay, so this one is the same. B has to be on the bottom. Okay, so here, B has to be on the bottom. Okay. Oh, why do my eraser seems not working here? Okay, good. Just erase off and at the same time. Okay, so here the B has to be on the bottom. So it's TB, all right, TBA, all right, and then this is E to the BXT. So this is a TAB, and this is a T over B. All right, we finally fixed it, but I guess you guys get the ideas, right? Okay, so this is very important. So it's ready to do some examples here. Okay, so example shouldn't be this complicated. So, but make sure you know how to get the moment, right? So like what we show in here is extremely important, right? So what is the first derivative, what is second derivative, what is the third derivatives here? Okay, now number 7, let's take a look. So number 7 is find the moment generating function. And then use this moment generating function to find the R's moment. All right, so let's hear. So moment generating functions, right? So by the definition, MXT. All right, so this is E to the TX. Then times f of x is E to the negative of x dx, right? So negative x dx is from 0 to infinity. So if I combined it a little bit, this is negative x, and so this is 1 minus t dx. So the integration, so I hope you all know how to do the integration. So this is 1 minus t, and then this is e to the negative x, 1 minus t, then plug the lower and the upper bound. And then I will have this one is equal to 1 over 1 minus t here. Okay, so now in here, I know, so this is back to the Maclaurin series again. Okay, so for the Maclaurin series here, right? So I know this one's here, right? This is my moment generating function, xt is equal to the 1 over 1 minus t here. One way you might ask me, you say, hey, why not I just take the derivative? You can do that, but it will be what? It will become pretty complicated here, right? So what I like to do is say, okay, now in here, I will change it to the Maclaurin series. So this Maclaurin series here, this will be here, it will be t plus t squared plus t cubed plus t fourths, So from here to here, I strongly recommend you, if you don't remember how to do the Maclaurin series, you can review that, okay? So this is what the Maclaurin series. And now I'm going to match. So remember, right, like in here, we did here, right? So if I can say it's 1 minus mu t, and then like t squared mu 2 prime, that's mu 3 t3s, right? So what I'm trying to do is here, I'm trying to match it, right? So here, let's see here. So here, okay, be careful, right? So this one's here, this is 1 plus, right? T really is 1 over 1 factorial t's, right? All right. So t squared. So what is t squared? T squared will be 2 factorial over 2 factorial t squared. And the 3 is 3 factorial over 3 factorial t cubed, right? Plus da 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 plus r factorial over r factorial t to the r, right? Okay, so instead of flipping back and forth, I want to write it out, what we just did in the previous pages here. So we know that mxt is equal to the 1 plus mu t plus t squared 2 factorial mu 2 prime plus mu 3 prime 3 factorial t3 plus da 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 mu r prime tr da da da. Okay, so compare it, right? So in here, so I know, okay, so compare these two, right? So this is t squares, right? So t squared, for example, like use these terms here, t squared. So you need to have a 2 factorial. So I have a 2 factorial here. Now what is this one on the top here? Huh? So this one on the top would be your what is mu 2 prime. Correct? So correct the same thing like T3 here. Take a look at T3. So you need to have a 3 factorial. So I have a 3 factorial. Now what happened to the top here? Top here is what? It's 3 factorial. So what is the 3 factorials here? So 3 factorial is the mu 3 prime. So in here they say, hey, find what is the R's moment. So what is the R's moment for this province here? So the R's moment is what? Is the R factorials here. Right, so it's these terms here. So that is the R's moment of this PDF. Correct? Okay. Good. Okay, so now let's take a look at the next ones here. So the next one, okay, so this one's here, let's say, given that x is the probability distribution function, is discrete, is 1 over 8 and 3 of the x here, right? X equal to 0, 1, 2, 3. I want to find the moment generating function. And then from the moment generating function, I want to find the first moment and the second moments here. Okay, so let's take a look at moment generating function, mxt is equal to the etx, right? Okay, so the etx, the probability is 1, 8, so I can take the 8 out. So this is a summation, like the e, the tx, and the 3x, right? And then x equal to 0, 1, 2, 3. Okay, so now let's see here. So this is 1 over 8. When x equal to 0, so 0, so it's 1 times 3, take a combination of the 0. All right? Okay, now when x equal to 1, when x equal to 1, so it's e to the what? E to the t, right? E to the t. Then this is 3 to the 1. X equal to 2, so e to the 2t and the 3 to the 2, correct? Then plus e to the 3t, 3 to the 3. Okay, so if you simplify it, so this is 1 over 8. So this is 1 plus 3et plus 3e2t plus e3t. And Now for here, you find that this is pretty cool. So this is 1331 here, right? So this is 1331. So what is this one? This is our expansion for the a plus b cube. So I can find this is 1 over a, 1 plus et to the cube. Wow, it's really pretty, right? So the moment generating functions, so I got it. So for this one here, the mxt is equal to the 1 over 8, 1 plus et to the cube, right? So if you expand these ones here, if you FOIL, this will be a cube plus 3a squared b plus 3ab squared plus b cubed. So in here, a is 1, the b is equal to what? Et. See here. That's why you can get this one. Okay, so now I'm going to find the first moment. So what I need to do, I need to take the derivative for t. So I'm going to find the first moment. Okay, so the first moment, so the derivative. So this is 3 over 8, 1 plus et to the second derivative, right? Second. Then chain rule et. Okay. Now you want to find the first moment. So it's the first derivative mxt dt, right? Now, which number you let to 0? T equal to 0, right? So t equal to 0, you will have a 3/8. Then this is 1 plus 1 to the square times 1, right? Okay, so it's 3 times 4, so it's 12 over 8, so it's 3 over 2. Right, so this is the first moment. So it's the first moment is mu1 prime. Also, it's mu, right? So if you want to see the first moment, right? Okay. Now I want to find the second moment, right? So this is they want us to find the second moment, right? Okay. So the second moment, that means I'm going to take the derivative of this one, right? So that means it's the second derivative, mxt. Now I need to take the t the second time. Okay, so this will be the 3 over 8. Okay, so now in here, you do the product rule. So this is 2, 1 plus et. So have 1, you have et. Then here you have another et. This is the chain rule, right? Then hold the first one. So this is 1 plus et to the square. And then take the et. So still is et. Right, so that what will be your derivative. So you use the product rule and then don't forget the chain rule. So the second moment will just be, you take the derivative here, the second derivative, then you let the t equal to 0. So you substitute the t equal to 0. So you will get a 3/8. This is 2 times 1 plus 1 times 1 times 1 plus 1 plus 1 to the square times 1 here. I got is 3 over 8 times 8. Yes, okay, so it's 3. So this will be what is the second derivative, right? So this is the second moment from the center. So it's mu2 prime here. Is it fun? Okay, so I think that's fun. Okay, so now let's take a look here. Okay. Now the last problem is here, right? So the last problem. Find the moment generating function of a random variable. Then I need to find the mu1, mu2, and the sigma. Oh my gosh. Okay, so let's do the moment generating function. Okay, so just like always, right? So like always, the moment generating functions will be mxt. So let's do it one more time. So make sure we are good at it, right? So etx here. So this will be the etx times 1 because the PDF, that's not bad, dx. And from 0 to 1. Okay, so the integration will be t to the e to the tx, right? And 0, 1. So 1 will be t, so this is et, minus when substitute 0 is t is 1. Okay, so this will be equal to t. This is the what? This is the et minus 1. Okay, so this is the et minus 1. And now you say, okay, let's take a look at the first moment. So you say d and xt dt. Okay, so you say, okay, the quotient rule, so it's t square, then this is like t times et, then minus et minus 1, right, by using the quotient rules, correct? And now, then you say, okay, set the first derivative, mxt dt, let's set t equal to 0. Then you set 0. Oh, this is 0. Oh, this is 0 minus 0. Oh my gosh, I got 0 over 0. That doesn't look too good, right? That's not look too good. So well, I stuck, right? So what do I need to do? I said, let's think about ET. All right, so okay, so maybe I can try to a different way instead of just doing the derivative because they're not cooperate. Okay, so you said, I know I can do the Maclaurin series again. So ET, right? So the ET will be, the Maclaurin series is 1 plus t squared over 2 factorial plus t cubed over 3 factorial plus da 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 da, and then minus 1 here, right? So this is the Maclaurin. This is the Maclaurin series, and this minus 1 is from here, right? And then here, this is t's here, okay? So here is the t's here. And then you see here, you say, hey, this one and this one cancel, right? Okay, so far so good. All right. So now I have, so t over t, what is here is 1 plus here. You cancel 1t, so what is here? 2 factorial t, right? Then the second term here is what? 2 factorial, so 3 factorial and t to the square, because you cancel 1t. Then you know this is t to the cube and the 4 factorial, then da 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 da. Then you say, this one probably is getting better. Okay, so now let's see we can derivative, right? mxt. First derivative. Okay, first derivative. This one cancel. So it's 1 over 2 plus, this is 2, the 3 factorial and the t, then plus 3, the t square, 4 factorial, right? Then da da da. Okay, so now the first derivative, et, let t equal to 0. But I got it, it's 1/2. It's very good. So what is this one? This is the first moment about the origin, or you can say it's mu. Now let's do a second derivative. Okay, now it's getting better. So this is xt, so this is the second derivative. When the second derivative, what happened here? Oh, this one becomes 0. So this is 2 to the 3 factorial plus, so this is 3 times 2, the 4 factorial, have a t here, then da 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 da. Okay, now let's see here, the mxt, the dx dt square. When the t equal to 0, what I have here, hey, all these terms, I have a 2 over 3 factorials, right? So what is the 2 over 3 factorials? Is 2 over 6 is 1/3. All right, so what is this one? Second derivative is the second moment about the origins, right? Now I get the sigma square. Sigma square is what? It's the second moment about the origin minus the first moment square. So this will be 1/3 minus 1/2 square. And what is the answer? 1/12. All right, so that's it, right? So that is how the moment generating function help us to find the moment. Like I said, sometimes if you just directly jump into the take the, the derivative, like what we did, over here. If you say, okay, let's just check the derivative about the moment generating function, then I end up with 0/0 is undetermined. I don't know what is that, right? So that's why you need to think about, maybe I can change it to the Maclaurin series. And so like in here, you see like a couple examples, we all change to Maclaurin series and make the things easier, right? So remember, the first derivative is the first moment, the second derivative is the second moment, right? So that is very good functions here. And then that's it. And we finally finished, the moment generating function and moments here. And our next topic, we're going to talk about how about if you have more than one variable, so one random variable, I have more than like 2 or 3 random variables. How do I find the moment? What type of the moment we're going to look for that? All right, that's it. And it's nice to talk to you, and hope you love the moment generating function. It really is a good function, very useful function. That's it. Have a good day, and I will talk to you in the next videos here. Okay, bye.